So, hello everyone. As Anika said, I am presenting from the RESESS Boulder program, and I was spending my summer looking at, well, for the fill and spill mechanism with ground penetrating radar at Panola Mountain, Georgia. And yeah. So in the early 2000s, hydrologists led by Trump van Meerveld created an extensive data set at Panola Mountain, specifically along this hill slope highlighted in green right here. This data set transforms the thinking of hill slope hydrology with the mapping of the depth to refusal surface, which is the depth to which you can no longer hand auger further, or for the purposes here, you can think of it as the subsurface topography, as well as the maximum rise well information, or where subsurface ponding occurs, provided by punching a bunch of holes into the ground seen over here. And they dug a 20-meter trench 2 meters up the hill slope seen here and highlighted in brown over here. What they eventually discovered with all this data at Panola Mountain was a method of water movement along the hill slope known as the fill and spill concept, which describes how groundwater follows subsurface topography, filling depressions past their storage capacity, spilling over into the next depression. Since we can't punch holes everywhere, geophysics is a great method in order to look down into the subsurface to comprehend water storage and movement with minimal disturbances to the ground. In the summer 2021, the Bedrock Critical Zone Network collected an extensive amount of geophysical data at the same site seen here with this in mind. So my summer was spent comparing this new 2021 geophysical data set with this 2000s hydraulic data set and visualizing it. So for the scope of the summer, I focused on ground penetrating radar, or GPR data, and specifically in this blue region here. Our two main questions this summer were, what is the transformation matrix, or the equation that aligns these two data sets? And does the GPR data indicate a depth to refusal along with clues of a fill and spill mechanism? So instead of throwing tons of math at you due to time, I'm going to tell you that the transformation matrix does exist and has taken much longer to find than you might expect. And this is how that data looks offset from each other. So you can see all the different layers. So top to bottom, we have an early 2000s ground surface, the 2021 ground surface, a maximum rise water table from one of the storm events, the Stilling Well locations, our interpolated depth to refusal, the early 2000s depth to refusal, and GPR lines. There still remains some uncertainty around matching up these ground surfaces with some future methods to implement to minimize that error, but with the limited time available to us, we decided to move on to our second question. Picking the 10 GPR lines that reside closest to the Stilling Wells of the maximum rise water table to not be misled by interpolation, I then did a qualitative analysis of GPR with these surfaces through facies classification, which is identifying patterns in GPR reflectors. So in this presentation, I'll show you one GPR line from 8.75 meters upslope from the trench and another one that's 17.5 meters upslope from the trench. And here are those two GPR lines which reside across the hill slope. The orange is the interpolated depth to refusal. The blue are the maximum rise water table events with the transparency indicating how much precipitation occurred in each storm event. The green line is the GPR ground surface and the black rectangles are the Stilling Wells. So the left line is downslope, and in the subsurface, we expect to see a bedrock ridge based on the interpolated depth to refusal in previous studies. In terms of GPR facies, this appears as a parallel to sub-horizontal reflector along here, confirming our interpolated depth to refusal. The right GPR line is upslope and based on previous studies should reside along a bedrock depression, which is a bit harder to make out with the depth to refusal here. However, through the maximum rise events, we can clearly see lateral flow in response to different events across this lower lying area. With the GPR facies that occur in these same areas, this is evidence of a fill and spill mechanism along the hill slope. Majority of the facies in these wet areas are categorized as sigmodal divergent reflectors with minor discontinuities, which are represented in these areas, or hummocky, apparent to faint subhorizontal reflectors displayed here. While dry spots that aren't ridges tend to be more consistently parallel to subhorizontal, rich and sparse reflectors seen here. Our results are still a bit inconclusive in terms of how these species relate to the maximum rise water table, but they provide promise as these patterns exist. Our initial hypothesis is this is due to the difference between lateral and vertical flow in these species. So in conclusion, the transformation matrix does exist, but requires further investigation of the ground surface to verify that anthropogenic activity did not change the landscape, which could be done with LiDAR. The GPR does show hints that our depth refusal surface is on the right track with facies and early 2000s data aligning where we think it should be. But these are super early results and a deeper analysis of the GPR needs to be performed. And quickly, I would just like to thank my amazing mentors for taking me on this summer. Thank you to my fellow interns and UNOFCO again, and I would like to point out my land acknowledgement here at the bottom. Thank you for listening, and I'll take any questions you may have.
Good job, Sam. Okay, questions for Sam. I already saw it. Lon has a question.
Remembered to unmute this time. Nice presentation, Sam. That was an exciting project. So you had said at the end that you felt like things were a little inconclusive. How might you test this? Are you thinking about going to another hill slope, doing GPR, making predictions, and then putting in stilling wells?
So one of the ideas they had is kind of, I think with like actually coring at some of the spots and confirming that there are what am I trying to say? My mind is kind of like on classes right now. That, you know, the soils that you would expect to see are there. And partially it is that I'm not a GPR expert, and a lot of this was me Googling GPR reflection information. And so I think a more in-depth analysis with, you know, comparing other known GPR reflections of critical zone areas. I don't know, my words aren't working.
Oh, that makes sense to me. Thank you.
Okay. Any other questions for Sam? Oh, I think okay, never mind. Any other questions for Sam? David.
Sam, in that slide, you had all the different layers. The very top layer was the ground surface in 2020, and then the next surface was the ground surface in 2021. So did a bunch of it get eroded, or what am I missing there?
So
Or is it just separated out to see?
That's partially our question. It is separated out to sea, but the surfaces don't quite align. And it is a question of, do we not know where exactly those control points are? Like, has it been eroded? Or it's hard to find exactly where they surveyed originally. And so, and it's hard to figure out where, like our little 20 by 20 meter ground surface is hard to find on this larger surface, especially because we don't have our one control point where we know there's bedrock in this area. And if we did, we'd be like, okay, this is where we know there's bedrock, so we could, you know, more easily find it. So there could be erosion, but it's hard to say.
Thanks.
Kelsey has a question. She would like to know, besides project scope, how was your second year of recess compared to your first?
I absolutely loved it. I mean, I loved both of them. Equally great years. I don't know how.
Like,
in
did
what
you?
way?
Oh wait, let's see. Oh no, someone else. So you opted to go somewhere else for your second year, where some interns opted to work with their same mentors or do something different in Boulder. Was that beneficial to you? Do you think that was a good decision for you and where you'd like to take your geoscience career?
Definitely. Yeah, I definitely think that was a wise decision for me because I really wanted to get a better grasp of different parts of hydrology. And I really enjoyed my previous mentor and I really enjoyed my previous project, but I really wanted to take a deeper dive into a different part of hydrology. And so this was a good experience and I really enjoyed the lab I worked in and I really enjoyed my mentors. And so I think it was a really great experience. I wouldn't trade it.
Okay.